Okay, so it says the graph of g is shown below, and g of x is, capital G prime of x is equal to g of x. That just means capital G is the antiderivative of g. If you take the derivative, you get regular g. So anyway, it also tells you that the area, because remember the integral represents the area from 0 to 2 underneath g of x is 16. What does that mean on the graph? The area from, I'll do it in red, from 0 to 2, so this area is equal to what? They said 16. So that area is 16. And then they also said that the area from 3 to 6 is 9. So what's that? That's from 3 to, looks like 6. This area is 9, right? Because it's got to go from there. Yeah. Okay. So to get the area from 0 to 6, I just have to find the area of that triangle. But wait a minute, how the heck did I know that I just need to do that? Well, we have this, and if you remember the fundamental theorem of calculus, it says if you have g of b, or capital G of b, minus capital G of a, that's going to equal the integral from a to b of lowercase g of x dx. So I'll just set it up like this. I have capital G of 6. Maybe I'll write this on the side. Capital G of 6 minus capital G of 0. So G of 6 minus G of 0. We want to know what the heck this is. But from the fundamental theorem of calculus, I know that that's just the integral from 0 to 6 of little g of x with respect to x. So this, since it's an integral, it's saying what's the area under g of x from 0 to 6. And that's what I was talking about over here. The area underneath g of x, which is that function, from 0 to 6 is 16 plus 9 plus that triangle. So what's the area of that triangle? Looks like I got a base of 1 and a height of 2. So 1/2 times the base times the height. That just gives me an area of 1, so plus 1. So I get 16 plus 9 plus 1, that's 26. So g of 6 minus g of 0, that corresponds to the integral, which corresponds to the area under the curve. So then you just find the area under the curve. There you go, so that's 26. Hopefully that helps.